Welcome back to another awkward video with me, Miss Redwick. I've just drawn a abridged version of our unit circle with all the points in the first quadrant and then just the other three, I guess I would say, major corners, pi, 3 pi over 2, and 2 pi. Today we're going to talk about the graphs of sine and cosine. So, just like other functions, sine and cosine can be represented as graphs in the xy plane. Instead of x and y, though, we're going to call our x, or our input, theta, the angle that's going into sine or cosine, and our output is going to be sine of that angle or cosine of that angle. So, let's start with sine. I'm going to start just in the positive angles. So this axis is theta, our angle that we're putting into sine, and it's always going to be in terms of radians. Our x-axis is going to now be theta in radians. And our y-axis is going to be sine of theta, whatever the output of sine of a certain angle is. So for example, sine of pi over 6 is 1/2. So at pi over 6, theta is pi over 6. Sine of pi over 6 would be 1/2 on my y-axis. So our input, or our domain, of trig functions is always an angle measure. And our range is either sine or cosine, whatever the output of that trig function is, which is usually some kind of triangle ratio. The ratio of certain side lengths. In this case, it's 1/2 over 1. So I'm going to plot different angles along my theta axis. And usually we're going to kind of just mark the big ones after we kind of build the graph, the big ones being like 0, pi over 2, pi, 3 pi over 2, 2 pi. And we're going to start at 0 for our angle. What's sine of 0? It's the y-coordinate at 0 on our unit circle. 0. So I'm going to put a dot there. And now, I'm going to go to my next one. So what's sine of pi over 6? I'm going to go, actually, I'll mark the things on my axis first. 2 pi is where I'm going to stop for now, even though it will go on forever, right? We could go infinite angles in either direction, positive or negative. We could keep going around the unit circle forever and ever and ever. We could put 100 pi on here if I want. So this domain is gonna go on forever, but our range, as you'll see, will be restricted. So I have pi in the middle, and then pi over 2, 3 pi over 2. These are all kind of like the quarters. And then in the middle I have pi over 4. I'll put pi over 6 is in here, pi over 3. So, at pi over 6, I have 1/2. I'll put 1/2 up here. At pi over 4, I have root 2 over 2, which is a little bit bigger than 1/2. It's 1/2 times root 2, which is just a little bit bigger than 1. So it's a little bit higher. And then at pi over 3, I have root 3 over 2, which is slightly bigger, actually, than root 2 over 2. So it's going to go up here. And then at pi over 2, my sine is 1. And now we can keep plotting some points. We can plot them along the rest of our small ones, but they're kind of close together. And they're going to start to follow a pattern. So if we skip all the way to pi, right, our sine of pi is 0. We're going to come all the way back down to 0. And there are the other points in here which are going to go back down, right? The sine of 2 pi over 3 is going to be, again, root 3 over 2. So it's going to come back to that same point, and so on. So they're going to mirror each other as we go back down. And then we can go all the way back down to 3 pi over 2, which is -1. So I'm going to put -1 down here on my sine axis. So -1 is the output at 3 pi over 2. And then back at 2 pi, my sine is back to 0. And then if you keep going around the circle, it's going to keep following that pattern. So if I connect all these dots, we're going to have what we call a sine wave. And it's going to be repetitive, or what we call periodic, and it's going to keep continuing every chunk of 2 pi. We can do the same thing for cosine, and I'm just going to plot it on the same graph, because the theta coordinates are going to be the same, but instead, so now we're going to use a different color to mark cosine. So our x-axis is still theta, and our y-axis now is going to be the output for cosine. So we're going to start at the same point. We're going to start at 0, and if you notice at 0, when the angle is 0, when theta is 0, cosine is our x coordinate in our unit circle, so cosine is going to be 1. So we're going to be up here. And then we can keep doing the same thing. At pi over 6, it's going to be root 3 over 2, which was kind of over here. It's a little bit less than 1. And then at pi over 4, it's going to be root 2 over 2. So these will be the same point. At pi over 3, it's going to be 1/2. So we'll be down here. At pi over 2, cosine is 0, because we're on the y-axis. So we're going to be down here. And it's going to follow the same pattern, similar to sine, kind of as we go, and it's going to follow kind of a wave cyclical pattern that's symmetric. So we can kind of hop to pi, and we know that it's going to be -1, right? Our x coordinate at pi is -1, so cosine has to be -1. And then at theta is 3 pi over 2, our cosine is going to be back to 0. And at theta is 2 pi, our cosine is going to be back to +1, all the way up here. So this one, if you look at the dots, it kind of looks like a V almost, but it's actually going to create more of like a, my dots aren't really spread out that well, but it makes kind of like a curvy wave. It's actually the same pattern or the same shape wave of our sine curve, just shifted over pi over 2. So like if I took the sine graph and shifted it over pi over 2 this way, slid my purple graph over to my light blue graph by pi over 2, they would land on top of each other. So that's the first, what's called period, or wave chunk, one complete wave for both sine and cosine from 0 to 2 pi, or one trip around the unit circle. Thanks for tuning in. Remember to subscribe, unsubscribe, resubscribe, like, favorite, share with your friends. Smash that notification button.